Hello, is this on? Ino nakano kawazu, taikai o shirazu. This is a Japanese proverb that means a frog in the well does not know the great sea, which I believe is a good metaphor for international web application development. Okina umi no youni gengo ga aremasu. Demo watashi tachi wa webu application o kaihatsuro toki. Ido no nakano kaeru no youni. Jibuntachi no gengo dake o kange amasu. Demo webu wa okina umi no yoina mono desu. Sarah Allen desu. Mightyverse o kaihatsu shitemasu. San Francisco ni sunde imasu. That's about all the Japanese that I know. I come from America, where we speak a simple language that has a simple script with just a few characters. And but I've been working on a website called Mightyverse, which I'll show you now, which has somebody you might recognize, except that it is
Ruby の動的な性質は DSL を実装するのに特に効果的です。
So Mightyverse allows you to explore different languages with native language videos that are cross-translated into other languages. We have a website and an iPhone app in development. The website is built in Ruby on Rails. And today I'm going to talk about some of my experiences that I've learned in dealing with different scripts in different languages based on my work in Mightyverse. Now, when we use different scripts and to communicate different languages in web applications, sometimes we'll end up with what the Japanese call mojibake, which unfortunately doesn't have a direct translation into English. And this was a word that I learned long before I knew any Japanese. But it pretty much means just garbled characters. This happens when you get the wrong character encoding. Here's a few examples of different character encodings that are common. There are a lot more than this that exist. There's the Unicode standards on the left, 8, 16, and 32 that I will be talking about today. Japanese also has a number of popular encoding standards that I won't talk about, but are still used today. For some encoding vocabulary, we'll talk about code points. This is one or more bytes that describe a unique letter or character. The popular modern Unicode formats are UTF-8, UTF-16, and UTF-32. UTF-32 is a fixed width 4-byte format, which is really easy to deal with, but less frequently used than 16 and 8. UTF-8 that I'll be mostly talking about today is variable length, as is UTF-16. UTF-8 is popular because ASCII encodes in just a single byte. The high bit indicates that there may be more than one byte. And this is one of the reasons that some people feel that Unicode UTF-8 is culturally biased. This shows how Unicode UTF-8 is encoded. So if you've got 1 byte, the high order bit is a 0, and then multi-bytes, you can tell from looking at any single byte how many bytes the character is. And so it's really easy to pick up in the middle of a stream or middle of a file and be able to tell what a whole character is. It's a common format for internet and on file system as well. It's the default encoding for XML. It's the only encoding used for Flash. There are disadvantages, as I mentioned. UTF-8 can encode larger for certain scripts. It's possible to split a string mid-character. Also, it's been criticized for what people call excessive unification, which means that more than one character that happens to look the same is encoded with the same code point. So for the English speakers, this would be as if the number 0 and the letter capital O had the same representation, which would, I think we can all agree, would be difficult to deal with. In Japanese, there's multiple characters for which this happens, and people in the West may be less sympathetic to that than we ought to be. So also be cautious when you're looking at Unicode formats, because sometimes the implementations aren't complete. I was surprised to find that MySQL 5 supports only 3 bytes for UTF-8. I figured, what's one more byte? But the first 3 bytes are used to encode what's called the basic multilingual plane, which is most modern spoken languages. Their scripts can be represented in these 3 bytes. The 4th byte is used for mathematical symbols, cuneiform, some Chinese characters, and for Klingon, which is a spoken language, I suppose. And they actually applied for part of the Unicode standard, and it was rejected in 2001. But there is an area of Unicode that you can use that requires 4 bytes that is for private use. So a number of Klingon speakers and writers are using a specific area of Unicode. Also Elvish, which is written in the Tengwar script, requires 4 bytes. And it's notable that when you're using Unicode, and you might not notice this if, because modern computers have a number of scripts installed, but if you don't have the right font installed, you get Mojibake. This is Elvish without the script installed. So next I'm going to go through something a little more practical now that you have a foundation in multi-byte concepts and Unicode concepts, which is a story of building a simple web application. So I'm going to go through 4 steps. An HTML form post, what you do in your Ruby code when that's received, how you write to the database and what's involved in that, and outputting HTML for display. Step 1, the HTML form post. So you have a number of HTTP headers. The accept char set is a way for the client to tell the server what char set it wants back, what type of script it wants back. This is purely informational. Most of us who write web applications control the client and the server, in which case this doesn't really matter. It's not going to change your behavior. But this is good to know if you're writing a application for which other people are writing their clients. Step 2, Ruby code. So most web applications don't actually parse text. In Mightyverse, we get some text from the user, and we tuck it away in the database, and we fetch it from the database, or we call a search engine. But we don't actually modify the text in the web application code. However, if your code does modify text or parse text, you'll need to think about Ruby 1.8 or 1.9. In Ruby 1.8, strings are dealt with just as a series of bytes. If you look at index 4 of a string, you'll get an ASCII code, and then you have to then convert it into a character. If you have a multi-byte string, as here we have konnichiwa, and you look at index 2, you'll get a single byte representation, which doesn't make sense as a character. In Ruby 1.9, this is dealt with beautifully, where if you index into a string that has regular ASCII, you'll get a character rather than the character code. And then if you index into a multi-byte string, like konnichiwa, if you look for index 2, you'll get the E symbol, which is what you'd expect. a whole character rather than part of a character, which is never quite the right thing. So we use Ruby 1.9. If you must use 1.8, there's a J-code library, which will provide string parsing and iterating through strings, through characters if you need it. The third step is where I ran into the most challenges dealing with multiple scripts, which is talking to and from the database. And this is not specific to Ruby, but many of us who build web applications still need to deal with it. So in the database, it's actually multiple steps. You have character encoding, where there's 3 different places that character encoding is set, and collation. So you have your database driver, which has a specific encoding, which is typically dealt with in configuration. Here I've shown the MySQL configuration options. I actually use Postgres, even though we don't yet have Klingon in Mightyverse. We now have 4-byte support through Postgres. Anyhow, the database driver, in this case the SQL client shown here, has a specific character set. Likewise, the connection, how bits are transmitted from client to the database, has its own character set configuration typically, and then the database itself, how is it stored. And I've never seen a reason that these wouldn't all be the same. When they get out of sync, I've run into problems where the text gets garbled. So check your database settings. Always use the same character set across. So I'm using UTF-8 for examples, but all of this would apply to a different character encoding. Collation. When I first ran across this word, I didn't know what it meant. I vaguely remembered collating things in a reproduction machine. But it describes sorting and how sorting differs in different languages. As an example, I have a list of Swedish towns and a German list of countries. You'll notice that the Swedish character, that's a capital A or capital O with the diacritical marks above it, which I'm told are not an umlaut, and that there's no correct way to describe in English. But Swedish is not one of my languages, so I don't know what those letters are. Anyhow, they're at the end of the alphabet. Swedish has 9 vowels. These are considered specific letters. They're not decorated vowels. German has an E character, which is the A with the umlaut, which precedes the capital A. And likewise, the O, I don't have a second O here, but the E precedes the O character. And as you can see, there's no way to sort a list correctly that includes different languages. So that's really challenging. What the web will typically do is just sort things in UTF-8's format, which is a sorting according to the byte order, which is kind of wrong in most languages. It's actually correct for Swedish. But there has to be some compromise. And what we're seeing more and more is that things are sorted in these language-neutral ways, even when they're a single language. So collation is important because it's not just used for sorting. People are pretty resilient to things being sorted a little wrong, but it's also used for equality. And I wanted to share with you a case where this came up, where we were moving to a different server and we ran into a problem that caused me to learn a lot about collation. So we moved to a different server and we had a uniqueness constraint on a table in database, and it was suddenly violated even though our data hadn't changed. And we isolated it to this SQL expression where we found that America was equivalent to America, and these are 2 different strings, and those of you who know Spanish will know that the E without an accent is a completely different character than the E with an accent, like Swedish, as I was saying. So MySQL lets you look at these characters and these expressions by encoding the strings differently. So you could see that with the Latin encoding, America and America are 2 different, are evaluated to false. But we were seeing that with UTF-8, they were the same. And this is kind of mysterious because in the UTF-8 encoding, these are actually different code points. What we ended up looking at is that in UTF-8, if you do case-insensitive collation, which is really used for when you want to do a case-insensitive compare, they were evaluating to true. If we change that to a UTF-8 binary comparison, that compared correctly. So this is actually not a bug, even though it seems like it to me. This is how this collation is documented to behave. So it's just a cautionary tale. Some of these details, once you get them right, it's easy to forget that there's any problem. But sometimes it can take a little attention to get them right. So onward, outputting HTML for display. So this is pretty straightforward. You can specify the content type. So the content type can either be displayed in a meta tag, which is part of your HTML document, which is recommended because then wherever your HTML document goes, then it's the right character set. You can also specify it in the HTTP header, and then the browser will observe that when it's displaying the characters. Most browsers these days will also let you dynamically change the character set, which is really handy for debugging. So that concludes my talk. You can now be frogs in the big wide world. And does anybody have any questions?
Any questions?
Yes, I have two questions. I'll just go one by one. First, about collation, you said it's impossible to have the Swedish collation and the German collation at the same time. You said it a little bit different. You said it's impossible to sort this data consistently, both the Swedish and the German one. Shouldn't the collation be determined by what the user expects, so that I sort the German way for a German user and the Swedish way for a Swedish user, independent of whether that's the data is German or whatever?
Absolutely. So if you have one page that you display for the Swedes and a different page that you display for the Germans, you should absolutely collate them according to that language. But as is the most classic example is when you're displaying a list of languages, you typically display them in the language of that somebody can read. And that has to be a fairly arbitrary sorting. I mean, you can sort some things realistically, but then other things are different things sorted together. So if you want multiple languages sorted, that's where the challenge happens.
Okay, fortunately Swedish and Norwegian and Danish don't start with one of these letters, so the Swedes can pick Swedish where they expect it, but yes. The other question is, you said that UTF-8 was just an example, and you actually had an example except jar set where I think ISO 88591 came first before UTF-8 or so. But these days shouldn't be the device be that if you start anew, just use UTF-8 so that because something else you will actually restrict the number of languages you can store and process and so on.
So the question was, I said that UTF-8 here is an example, but if you were starting an application from scratch now, shouldn't you use UTF-8? And I'd say when I proposed this talk, that would have been my recommendation. However, in coming to Japan and realizing that I'm giving this talk to an audience who knows more about writing web applications in Japanese than I do, I don't actually know whether that is the universally correct recommendation.
Okay, I think it's not universally correct, but it's definitely a good recommendation still.
Yeah, I mean, I think UTF-8 is a safe choice on the web today.
Okay.
But yeah, there are a lot of scripts, a lot of languages where UTF-8 is going to be larger to store data than a native encoding.
Hello. So you'd said that on America and America, you can do a binary collate, and then this keeps America and America from collapsing into one entry. Is that accurate?
Well, it's not. So the question was, in doing a UTF-8 binary collation.
Without the binary.
without binary.
Do they sort of turn into one entry? Is that
They
the
don't
problem?
turn into one entry, but they have an arbitrary sort. So they evaluate to the same when it comes to sorting. So
I
they're equal. It's
see,
as
I
if they
see.
were capital and small e, where they'll be in
Okay.
the same place in the alphabet.
All right, thank you.
Hey, sorry. I just wanted to say about the UTF-8 thing. They're definitely, if you know for sure that UTF-8 is not good for some reason, like if you know you're dealing with a lot of shift-just data, then obviously there's a whole different story. But if you're starting a totally new Rails app and you're just like, how should I store my data? Should it be in, like, what do I want to set my database to? UTF-8 is a pretty good choice. It should, like today's UTF-8 should be able to store Japanese characters pretty reliably. And if you do use UTF-8 everywhere, like throughout all the pieces that attach to your Rails stack, that massively mitigates a lot of the problems that could exist.
So yeah, Yehud is just pointing out UTF-8 is a really nice choice for Rails. Yeah, and I also find that in dealing with a lot of client-side technology, often like Flash only supports one type of encoding. So UTF-8 turns out to be a really safe, nice choice. Another question over there?
One more question. For the collations, you showed what the database is doing, and databases definitely have collations. What about Ruby itself? Does it, or Rails, does it have collations, or should it have collations? And if yes, how and why? And
That's a good question. I actually can't have this. So the question was, I showed how the database sorted. How does Ruby sort? And I actually don't know the answer to that question. I was wondering that myself as I was preparing for the slides. But it definitely has a sort because it's a sort function. And anybody know?
Mine's another question, but is that okay to go? Just on the collation, again, back on the collation thing, if you have one database that's storing multiple languages, in Rails you usually use the sort in the active record query, but if you're sorting it in different ways for different languages, like Swedish and German, it means that you need to actually go and resort it using Ruby or something. And so does Ruby have some sort of collation setting so that you can resort it after calling the database query? And isn't it really stupid to actually have to rely on MySQL or SQL sorting and Ruby sorting? So you're actually having to sometimes sort twice.
So the question was, in dealing with multiple databases, you wouldn't be able to, dealing with multiple languages in the same database, if you wanted to present to the user the correct sort for their language, you couldn't rely on the database. Unless, of course, you had different, like Postgres 8.4, you need to have the same collation for all databases on one database server. MySQL actually allows you to have different database settings for different instances of databases in one server. So you could consider having the sorts happen there. Because it is a little crazy to not be able to rely on your database sort. Because the reason that most of us sort in the database is because it's more efficient. Because you typically don't want everything in your table. You want the topmost or the bottommost. And so it's crazy to have to pull in all your data and then sort it.
One more question related to that. Do any databases support collation by row?
Well, the question was, would there be correlations by row? I think you mean by table.
No, by row.
Well, then it does. You need multiple things to sort.
what do you mean by collation by row?
Yeah.
Well, at the moment you have collation by table, and I think everyone's quite familiar with that. But if you've got multiple languages in one table, then surely you need something to separate what language is what, apart from just a language pointer. But you'd actually need a collation and say, well, usually you'd be sorting it by language anyway, but to say everything that's Japanese, for example, would be the Japanese collation. So surely some sort of database technology would be there to say, okay, this row is this collation, that row is a different collation.
Well, so the challenge there is exactly the challenge that I was talking about, where UTF-8 provides a sort of generic, overly homogeneous sort. Because if you have one table where different rows have different languages, then if you have a data set that has multiple languages, you have indeterminate collation. So I don't know of anything that's solved that way.
I think basically what you're talking about is having a collation dynamically for a select, because if you're selecting a specific language, I guess that's not something you can do with current databases. Okay. Okay.
Somebody in the audience thinks you can do it by connection. So do we have time for more questions, or
For one short last question.
are there
Other?
any final questions?
大丈夫
All right, thank you for your attention.